All right, let's continue with part B. We have 2 minus 3 cosine theta and for x, and then 3 plus 2 sine theta for y. We are given 3 different points. So first of all, let's find dy over dx by using the formula dy over dt, dx over dt, and we use the same approach in part A, okay? So what is the, by the way, these are not t's but thetas, okay? Because the parameter here is theta, okay? All right, so dy over d theta is going to be 2 cosine theta, and then the bottom would be dx over d theta, the derivative of x. That is 3 sine theta, and that is 2 over 3 cotan theta by using the definition of cotan. So my next task is to see like what theta value or values correspond to those points, negative 1, 3, 2, and 5, and 4 plus 3 radical 3 over 2, and 2, okay? Because we need to know the theta values so that I can evaluate dy over dx at those theta values to come up with 3 different slopes here, okay? So the first one is negative 1 and 3, so just think about like what theta value can make x to be negative 1 and y to be 3, okay? So to make y 3, 2 sine theta is supposed to be, let me just write this here on a scratch. 2 sine theta is supposed to be 0. And to make x to be negative 1, we want negative 3 cosine theta to be negative 3. Okay, so this implies that sine theta equals 0 and cosine theta equals 1. So just think about like what theta value takes you to sine value 0, cosine value 1. So to find that out, you can in fact look at arc sine 0, like sine inverse 0, and cosine inverse of 1. So, okay, you can use your calculator to get those theta values, and you will see that those value, that value that we're after is in fact 0. So we have theta equals 0 for this case, okay? And then let's check these out for 2 and 5. So to make x equals 2, negative 3 cosine theta should be 0, right? And to make y to be 5, right? To make y 5, then 2 sine theta is supposed to be 2. So that implies sine theta equals 1 and cosine theta equals 0, okay? Go ahead and look at sine inverse of 1 and cosine inverse of 0. So, and check what your calculate cosine inverse of 0, right? That should be inverse, or arc cosine. And you should be able to get theta equals pi over 2, okay? And lastly, to make x equals 2, well, x equals 4 plus 3 radical 3 divided by 2, what am I supposed to choose for 3 cosine theta? Okay, negative 3 cosine theta. So that should be 3 root 3 over 2, right? Yep. And to make y entry, like y coordinate, to be 2, then 2 sine theta should be negative 1. So this implies that sine theta equals negative 1/2 and cosine theta equals, let's see, negative radical 3 over 2. And now, please be careful when you look at sine inverse and cosine inverse of negative 1/2 and negative radical 3 over 2. Be careful because we're in the third quadrant that we have both sine and cosine negative. you're going to probably get something positive out of your calculator, or maybe negative pi over 6, but you have to somehow like move that to the third quadrant to get the equivalent angle for that, okay? So again, one more time, sine theta equals negative 1/2, cosine theta equals negative radical 3 over 2, so that kind of theta is in the third quadrant. And arc sine and arc cosine of those values may not take you to the third quadrant, so in that case, please get the equivalent version of that in the third quadrant, and that should be 7 pi over 6. Okay? All right. So we're done with those. I can clean this up. And then now I can go ahead and calculate M1, M2, M3 real quick. M1, M2, M3. Okay? So at theta equals 0, dy over dx is 2 over 3 cotan 0, and go ahead and then punch this in your calculator, and it's undefined because it's cosine over sine, right? Sine blows up. I mean, sine is 0 at 0, so the whole thing blows up. Okay, and m2 happens at pi over 2, so cosine pi over 2, sine pi over 2 for cotan, right? So that is 0. Okay. So let's see, cosine, let me just double check, 2 cosine pi over 2, yes, exactly, so m2 equals 0, okay? And for 7 pi over 6, go ahead and use your calculator, but please try to use exact values because 7 pi over 6 is a known number, so this should be, let me just write this as 2 radical 3 divided by 3, okay? So now I'm going to erase this since we have all the slopes. And by the way, you can pause the video anytime and work through that by yourself. Tangent line 1, tangent line 2, tangent line 3. All right, so M1 is undefined. That means slope is undefined. We have a vertical tangent line. So the equation for that is x equals, we were talking about this point, so x equals negative 1 is the equation of the tangent line at that point. And for the second case, the slope is 0. That is, that's us having a horizontal tangent line. So we're going to go with the y-coordinate of the point, so y equals 5. And in the last case, we have, we're going to write down the point slope form explicitly. So y minus the y-coordinate equals the slope times x minus the x-coordinate. Okay? So then we have the tangent line of this form. All right, let's verify that what we have found is correct. So we have one vertical tangent line, one horizontal, and one tangent line coming with positive slope at different points, as you see here. So go ahead and use your TI-84 to graph this equation together with its tangent lines. You should expect an ellipse. Okay, so you can pause the video at this moment, in fact, before I show you what the graph looks like. Here we go. I have t equals 0, I have a vertical tangent line. I have a vertical tangent line here at this point. And at t equals pi over 2, I have a horizontal tangent line, as you see, the dashed line, right? And eventually at this point, I have a tangent line, which is the point, in fact, corresponding to 7 pi over 6, right? And I have a tangent line with positive slope, okay? All right, I think that takes care of everything. Please graph this and try to get the same graph and convince yourself that you're able to plot all of these tangent lines together with the graph of an ellipse. All right, I'll see you in another video because that takes care of both parts. And thanks for watching. Bye.